first video for 6.2. We're going to be learning 2 additional Riemann sums. So we looked at left and right last time. We're going to be learning about midpoint Riemann sums and trapezoidal sums as well as just reviewing and practicing left and right a little bit more. Okay, so we have this given function from 0 to 6. Partition the interval from 0 to 6 into 4 subintervals, okay? And notice these subintervals are not of equal length, so that's okay. We're just going to find each individual rectangle. So we're going to do the left Riemann sum to start. Okay, so I always like to put a little subscript so I know which area I'm finding. So our left Riemann sum is going to give an approximate area. Okay, so the first rectangle, so delta x from 0 to 1, that's a length or a base of 1, right? That's how far apart those x values are, so my delta x is 1. And then my height, right, we're using the left, so I need to know what is the y value at 0, so f of 0, okay? My second interval, my delta x is also 1. My left x value is 1, so we have to find the height at 1. Next interval, my delta x is 2. My left x is 4, so we're finding the height at 4. And then again, we have a delta x of 2. And then f of, oh, sorry, did this one backwards. My left there is 2, left here is 4. There we go. Okay, so we are finding the left heights. So to find each of those left heights, we take these x values and plug them into the function, x squared minus 3. Okay, so f of 0 is negative 3. F of 1 is negative 2. F of 2 is 1, and f of 4 is 13. So we just plugged in those x's to see what our y value was, and then we multiply these, add them all together, and we get an area of 23. Okay, now we're going to do the right. So this is going to look super similar. Our delta x's are going to be the same. So we have 1 times f of something plus 1 times f of something plus 2 times f of something plus 2 times. So my delta x's are the same as up above, right? But this time we're using the right height. So I'm using the right x value in each of those intervals. Okay, and then we do the same thing. So we get 1 times, we can pull a lot of these from up above. And then the last one we hadn't calculated yet, so f of 6 is 33. Okay, multiply those and add them all together, and we get an area of 91. Okay, so left and right, that's just review from last time. Now we're going to look at how to find the midpoint. So our area of the midpoint is, we still take our delta x as our base of our rectangle, and then we're going to multiply by f of midpoint x. Okay, so what this means, so let's look at our example for this particular one, so a little separation. Okay, so our area of the midpoint sum, okay, so our delta x is still the same delta x as we had it, so 1, 1, 2, 2, okay, so still 1 for this first interval. Now instead of using 0 or 1, we're going to use the halfway point between 0 and 1, which is 0.5. So we're going to do f of 0.5 plus 1 times, okay, now my second interval, halfway between 1 and 2, is 1.5. Okay, my third interval, delta x was 2, okay, and then halfway between 2 and 4 is 3. And last, delta x is also 2, and the last interval, halfway between 4 and 6, is 5. So this is what we mean by the midpoint x. It's the midpoint of that particular interval. And again, we're still finding the y value that goes with it to get the height, but we're not using the left or right, we're using the middle value. Okay, so I went ahead and did some calculations here, you guys. So f of 0.5 is negative 2.75. F of 1.5 was 0.75. and f of 3 was 6, and f of 5 was 22. Okay, so multiply those all together, add them up, and we get an area of 54. So this makes sense, you guys, that the midpoint area is between the left and the right, because I'm using middle values there. Okay, so that's midpoint sum. The last one we're going to learn is called the trapezoidal Riemann sum. So we're going to find the area of a trapezoid. So this is the one where we're actually not going to divide into rectangles. We are going to divide into trapezoids. So as a reminder, for a trapezoid, okay, so I'm just going to kind of draw. So let's imagine, okay, so let's say I have a rectangle here. Okay, so this and this height, so here's my delta x. This is a one height and this is another height. So in my trapezoid area, we call that base 1 and base 2. So these bases are parallel to each other. And then that connection right there, I don't need to know. Delta x is the height of the trapezoid. So our area is equal to the height, which for us is going to be delta x of our trapezoid. That's how far apart our bases are, times base 1 plus base 2 over 2. Okay, so that is how I find the area of a trapezoid. So instead of doing rectangles, we're just doing trapezoids. Okay, so let's look at this. So here's our function f of x. We're using a trapezoidal sum. We're using 4 subintervals of equal width. So every time my height or my delta x is going to be the same, so I can kind of pull that piece out. Okay, so how we find delta x is the same. We do b minus a of my interval, and then I divide by how many subintervals we want, in this case 4, so our delta x is 1. So our area using the trapezoidal sum, delta x, okay, I'm going to pull that out, and then I'm going to do this part. Base 1 plus base 2 over 2. Okay, so how do I get this? Okay, well, my intervals, you guys, because delta x is 1, my intervals are from 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So these are my x1, x2. So my base 1, base 2 is f of 1 and f of 2. So to find this, we're going to do f of 1 plus f of 2 divided by 2. So that is this part, and then times the height is going to give me the area of that first trapezoid for this interval. Second interval, we're going to do the same thing, but we're doing f of 2 plus f of 3 over 2. Okay, and then 3 and 4. And then 4 and 5. Okay, so again, because we had equal subintervals, I was able to pull that height out, delta x out all the way. Okay, I went ahead and did each of these, you guys. Again, how I got f of 1 is we're plugging 1 for x here. I went ahead and approximated. So I got 1 times f of 1 plus f of 2 divided by 2 was about 3.206. 5.195. Anytime you are approximating, make sure you round 3 decimal places. And 21.666. Okay, adding all those together, we get an approximate area of 40.239. So that is the last type of Riemann sum we're going to learn, is the trapezoidal. So we have left, right, midpoint, and trapezoidal. Okay. Okay, so here I have a graph, f of x, from 0 to 3. Which of the following has the least value or the smallest value? Okay, so imagine if I divided these, so notice they're all doing the same thing. They're doing 4 intervals. So if I separated this into 4 rectangles of equal width, right? Okay, if I used a left Riemann sum, so the left height, so if I go from the left and the left and the left. Okay, so if I do the left, this is going to be overestimating my area because it's going above the fraction. So I'm just going to write that. This is an overestimate. So this one probably is not going to be the least value because it's an overestimate of the actual area. Okay, now if I use the right heights. So right, 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 right. So these rectangles all fall underneath when I use the right height. So this is an underestimate. So remember, midpoint is always between the left and right. So far, B is my least value because it's going to be underneath. Now, trapezoid, if you think about it, when I do a trapezoid, I'm averaging the left and right? We're doing base 1 plus base 2 divided by 2. So it also is going to be between A and B. We'll talk a little bit more specific, but my least value is going to be B. Okay, so here's kind of some general rules of thumb to kind of help with that overestimating versus underestimating. So we kind of saw a perfect example. This one I'm actually going to fill in the middle first because this was a decreasing function. So when it was decreasing, the left is an overestimate and the right is an underestimate. So you can imagine if the function is switched and it's increasing, these two flip-flop. So the left is an underestimate when it's an increasing function, underestimate, and the right is an overestimate. Okay, and then trapezoidal, this actually tells us a little bit of something because it's a combination of the left and right because we're averaging those two heights when we find the trapezoidal area. And so we have, this rule actually depends on concavity. So if it is concave up, trapezoidal sum overestimates. And if it's concave down, it's an underestimate. Okay? And I think, yep, and that is it, you guys, for this video. Thanks for watching.